So, I'm still working out audio issues. I have not really been so concerned about all of that. I'm more interested in the work. Uh, this has been a long time in coming. The weather in the shop has been super, super hot. And so I finally decided that as it's starting to cool off, let's start getting into the shop a bit more. And we'll start working on the CNC router and some other projects. So I have been working on some QAing of the plates that I did, and we're trying to make sure that the work is good. And so you dry fit, right? And you do your measurements and you see how far off your work is from the original plan. And of course, learning as I go, uh, I was off by quite a bit on some of the earlier plates. And I would forget to do certain things on those plates. And as time has gone on, I've gotten a lot better at it. So, one of the issues I ran into some months back was trying to get this particular slot cut properly. And I didn't have my paths right, I didn't have my speeds and feeds correct. And as a result, a $45 bit wound down into the aluminum and its tip got stuck. And I had to drill it out. And so today we have this hole right here needs to be recut. So I went back into the drawings and did measurements with the calipers and the micrometer and figured out what the actual dimensions of the part are. And a lot of the holes in here are pretty close. A lot of it's not pretty, and I'm okay with that. And I did a dry fit, as you see in the original image for the video, and it was spot on. The holes were okay. So we're going to cut this final slot, and hopefully it'll all work out. I'll leave the video running. I'll try to have some background audio. I won't be talking a lot during this one. I have been told that I talk way too much. Um, Let me check and see. I thought I saw somebody trying to reach out to me here. I have alternate channels to get to me. Let's see who's up. Uh, all right, so that was probably just an anomaly, but it's okay. It's all right. So let's open up the other view so that you can see some of the things I'm doing, and we'll just carry on. There's a sign I was working on for a friend. Yeah, I was working on a sign, and I was using plywood to do that, and I had changed my procedure to try to use just some cheap plywood, and it was working. The procedure was working till we hit some rotted wood on the inside layers of the plywood. Here, I'll show you. So that's a garden sign for a friend. And interestingly, it uses the same roughing bit that we're going to use for the aluminum. But I finally learned to put down some kind of a laminate onto the wood. In this case, it was spray-on lacquer, and just a couple of layers of that, and it provided enough um, cohesion of wood fibers to prevent tear out. This particular bit is an up spiraling bit, so what that means is the parts of the wood are going to go upward. What I need is a down spiral bit for roughing out wood and fine cutting of wood. I just don't happen to have those right now. But the time will come when I'll have all the right bits. But for right now, I'm just doing some things for fun for a couple of friends, my wife and a friend of mine, to let them have garden signs. Nothing fancy, but it sure is a fun diversion from some of the other work that I do. All right, so let's get back over to the right display cam and bring in the flue mill cam, because I'm going to go over there in a minute and we're going to stage the next part and have it remilled. And I'd like for you to be able to see that process if you're so inclined. And I won't be running the vacuum this time. We'll just leave it free so you can see what's going on. But I got to take that piece of wood off of there and then mount up the next item. All right, well, here we go. Let's get that done. Oh, here we go. If I was one of those folks who did videos of the work that I do and didn't post-process the videos, I think you would see probably better quality of videos, but all my videos are live. So you get to see all the mistakes. And I don't care. Alright, because that's live, people. Oh, woo! Boy, that was a lot of work on that one. So it was welcome to the Garden of Whedon. And, yep. Oh, I see what happened. There were parts of the wood that are missing from the underlayers in the middle of the laminate. Like whole sections of wood are missing. So it was just poor quality plywood that caused this problem. And that particular wood, I will have to go back in through receipts and find out where it came from, because I just don't think I want to buy from that vendor again. Alright, now I need to get vacuum started. We got to do some cleanup here. So I could get power over there. I keep my aluminum vacuum cleaner separate from the everything else vacuum cleaner, because I don't want a thermite reaction in the shop. Oh yeah, those of you new to hobby CNC, let me tell you something. If you don't take thermite reaction seriously, you are going to burn down your shop. That's just going to happen if you don't take it seriously. So what is the thermite reaction? Take iron filings, combine them with aluminum, and then you introduce water from just moisture in the air, and now you have a thermite reaction. And it's so hot that it can melt pretty much everything. You're talking like little sunshine right there inside your well, I should say surface of the sun right there inside your shop. Oh, yeah, no good for anybody. Okay, let's get this vacuum cleaner started and clean up. So, You might say, but you don't have issues with iron filings because you don't cut iron or steel. Well, it's alright, you don't have to. Where does it come from? It comes naturally in the sand that you are trekking in to the shop on your feet. If you take a magnet outside on the ground, you can collect iron filings just by passing the magnet through the sand. It's there. Some places may have it more than others, but it's enough of a risk that you mitigate it simply by not allowing it to combine in our vacuum chambers. Yes, I said vacuum chambers, because that's what they are. It's not merely vacuum cleaner, it's vacuum chamber. It's a container that collects all the stuff you vacuum up off the floor. And some of that is iron filings. Not worth the risk. And I must tell you that it is definitely worthwhile to have a vacuum going when you are cutting wood. That was only my second time cutting wood on a CNC when I did my friend's sign. That's how new I am to all this. I can already see that one of my 3D printer projects, when I get that machine back up and running, is to cut out guards for the drive mechanism. Keep all the dust, sawdust, aluminum off of the drive mechanisms. I have considered, it's still up in the air, I have considered the possibility of moving the CNC router to a wall. Absolutely nothing wrong with that configuration. And in my space situation, it's likely a good idea. But I need to get some more feedback from other people and find out if that's working for them and what kind of issues they run into. Oh, I accidentally pulled in some aluminum. So I have to stop what I'm doing and immediately go dump this container because it pulled in some aluminum. We are not going to run aluminum and leave it inside the shop. We got to get it out of here. Don't need a thermite reaction. I'm going to go dump these sawdust in the burn barrel. Actually, I know a good place for it. Right here. There you go. That way, if that sucker decides it wants to ignite, it ignites outside the shop. There we go, in a safe location where it won't start a grass fire. Okay, and here we are. Let's get the lid back on. Gotta turn it around. Come on. There we go. Alright, vacuum's back in operation. And so now I'm going to stop working on that, and we're going to focus on getting our world set back up here. Yeah, I am breathing heavy. It's because my health has not been too good lately. But that's life. I ain't worried about it. You gotta do what you gotta do. Alright. And I've been thinking about putting a touchscreen up close. Once I get all the ashes sorted, I'd like to see about having a... There, that'll work. Alright. Let's give you a better view. Alright, so there we got a nice straight edge. And this isn't going to take much to get this done. We'll go ahead and double-sided tape this one. It's important to remember where 0 is. Super important to remember where 0 is. I had a problem with a sign that one of the two signs I did. I didn't place the 0 in the right location, and it caused me some issues. Nothing I couldn't fix. It's just one of those seriously moments. And the kind of stuff that causes reworks. Okay. Probably more tape than I need to put down. And it's the first time I've been out in the shop in quite a few days. We had a heat wave come through, and I had a guy come in and help with the yard work. Got quite a bit done between the two of us, but due to the heat, 3 hours into it, I was done. See, I'm an office worker, not an outside worker, so you lose some of that. And as you get into working in more sedentary work, and he works all the time physically, so he was ready for it. Some of you are going to look at the double-sided tape that I put on the workpiece and go, "Hey Earl, what about this wrinkle you got there?" And I'm like, it's not going to matter. You got to know the difference between what's going to matter and what isn't going to matter. My design has so much flexibility in it that there's some errors I can get by with. Some errors you cannot get by with. Okay, make sure we get 0 correct. I don't want to go through that problem again. I'm not getting 0 correct. Oh, motherfucker. Hey, this video is not for children. You should know that by now. But I will try to not let that happen again. In fact, I may wind up going back and deleting this video because of that one outburst. Okay, so I'm just going to sit here and hold this. I'll take that off since that's already broken. Yeah, I've got to come up with a rig that suspends my vacuum hose in the air, because I had the vacuum hose attached like that, and a human being or a dog hit the vacuum hose along the floor in front of the bench. I broke that right off. Yeah. Could have been me. Could have been the workman. Could have been the dog. I have no idea who. So we just got to keep moving forward. And if I can get a new one of those, I will. But what if you 3D print it? And I'm like, yeah, that's a good idea, but how much time do you want to spend doing that? Okay, so that's going to be ready to go. And we got to go get the device we're using as a pendant. This is already tight, but we're going to double check it. You should always double check it. You treat every initial job as if it's brand new. There, that's nice and tight. Okie dokie. Smoky. Let's put the cyanoacrylate glue away. CA glue, also known as, by the name everybody else knows it as, super glue. Yes, cyanoacrylate. Acrylic? Cyanoacrylate? Acrylic? One of those. So, in the background there, you see the path that this bit's going to take. It's almost nothing. But it took me a while to get the paths sorted out in contour mode without the use of any kind of lubrication. It was not easy to sort. I had to go through a lot of failures, expensive failures, I should add. And one thing led to another. And I just kept at it, kept at it, kept at it till I sorted it out. Whew. Okay. Alright, let's get to the right page here. We have a secure network inside the shop. I keep it in a separate VLAN for protection of all the systems involved. Here we go. So that's working. Now, let's get our... I started to learn how to do some things in the Hobby CNC to help eliminate problems. Learning the limits of what I can and can't do. Like, what's about to happen right now is I am definitely putting down some anchor screws, just 2 of them. So there's a fixture, and here's another fixture. Doesn't have to be fancy. There you go, 2 fixtures, and that's done. I could put down more. One could say, yeah, but you should put down more. I'm like, yeah, you'd be surprised. I haven't tested it, but that's a lot of force right there. And the cool thing about it is it gives me a place to clip. And now I need to test that and make sure we're actually getting let's see if I can home. Okay, we haven't gone red yet. That's good. No alarms yet. So I'm going to bring that in a little. It's off camera, but you'll see it here in a moment. Here it comes. Alright. Here we go. I'm just going to touch that. And you can see the red P. just going to touch the bit. See that? So that lets us know that we're indeed got contact electrically. And let's turn this little... When I first started doing this, oh my gosh, I was terrible at this. Oh boy, was I ever terrible at it. And I started working out my own macros for zeroing. That was a lot of experimentation. When you've paid a lot of money and zero profit for they show broken bits, probe Y, you start to become more careful because you're thinking about all the failures. But more so, it's not failures, it's what do I have to do next to keep that failure from happening? Okay, there we go. So we had a little issue happen here just now where it kept driving the Y probe. I'm not exactly sure why it did that. I'm not real happy about it. So because I'm unfamiliar with what just happened and the cause for it, I'm going to reprobe in the Y direction. I'm going to watch the screen. Okay, because I know the behavior of my CNC router, I know that this screen is correct. All right, and you're not seeing that, but that's okay, maybe next time. In fact, let's bring it up so that you can see it. I want you to be able to see it. Besides, I got to get the last job out of there, and you'll be seeing me produce the new job. I've already QA'd the path. I mean, the path is good. I've simulated it. Hopefully everything works out. So I'm sitting back over at the desk. Now, and I'm remoting into the controller, and I'm taking out the last job that was in there. I'm gonna discard that one. Okay, I can share with you. Okay, let's bring that down a little. There we go. And let's take out all of these print jobs. I don't need those in there. Alright, let's go. Exit that simulation. We're going to export that Q3 slot. Post-process that. The plate is literally named Q3 as in, well, QA3 as in it's supposed to be QA3, but that's okay. QA3. Okay. I've got a whole nother plate I got to completely redo. I'm not real happy with one of the plates that was used for the X-axis motor mount. It's horrible. So I will cut the entire plate. And that happens. I'm not even upset about it, just one of those things. And just, it was one of my earlier plates too, when I was learning how to use the CNC router early on. Okay, we're good there. Alright, so, so we're going to jog that controller over. I'm going to load that job, but we're not going to run it. See, if I were to run that job right now, that'd be the stupidest thing. Normally I don't load up these jobs, okay? Normally I wait until all my zeroing is done so there's no accidental launching of the job. Because if I accidentally launch the job, then it causes me to have to immediately stop it by hitting the kill switch. And when you hit the kill switch, you have to go back and zero all over again. Okay. So my creative juices are flowing, and my problem-solving skills are there, but my short-term memory is not. So I've been having to take lots of notes, like writing down a number. I'm finding myself having to write that number down in order to remember it. And that's just been happening in the last few days. It's external stress, and stress does that. Okay, but the reason why I'm doing work today is because I got tired of just sitting around Labor Day doing nothing. I need to do something. All right, we're going to probe Y again. Why? Because it's the safe thing to do. And you're getting a chance to see what's happening. See the y-axis counting down. You see how it stepped back 13.4 millimeters? I just happen to know that that's the distance I've told it to step back. So I know we've zeroed. So I turn my bit again. Now we're going to probe the X direction. It's going to go back in a little more slowly, just to be absolutely sure. And there it is, minus 13.4. Why that? Because I tend to use quarter-inch bits. That's why, for roughing operations. And when I get to a point where I need to use a smaller diameter, like a 1/8 inch bit, then I'll have to rework the math. And that's okay. I don't mind. It's all perfectly fine. Now this time I'm going to do something a little different. I'm going to do the Z very close, the Z zeroing very close to where I'm drilling, where I'm milling. I want it to be as accurate as possible. And yeah, the clearance heights are like crazy high, so we're going to be good there. This is not a commercial shop, okay? Not yet. It isn't a commercial shop, this is a hobby shop. And I'm less concerned about speed and I'm more concerned about quality. All right, that's good enough, okay? So let's bring it down some. There, we'll do Z0 right there. So we're going to probe Z. It goes down, it goes down, and it goes down. Okay, touch, now it's going to do it again. There we go. And on the Z-axis, that 10 tells me it's right where it's supposed to be, right? So I'm going to bring it up a bit more. Let's take these off. Leads are taken off. Now hopefully I don't break the bit. Okay. Go to XY0. Looks about right. And I'm going to go to the run file and start it. Now it's not moving around a whole lot, and there's still a chance that the bit could get locked in there, like it did last time. But the path is much slower this time. And in fact, I'm going to give it some lubricant. A little bit more. I think this is a silicone-based lubricant. It's tiny little elongated racetrack pads, for lack of a better word. But if you look at the path, it actually looks like a little racetrack. So there is work happening here to clear out the chips. And the chips here are a little small. I'd like to see bigger chips, which means my speed is probably too fast. So I'm going to slow it down. I don't think I want to go any slower than that. The feed is probably too slow. You don't want the chips to be like grains. There, is it starting to do chips? Nope. So we're having some issues with chip evacuation. That's what I'm seeing. And it's doing some chip welding. So rotation is still too fast. So that's where it's having some issues right now, is with chip evacuation. That's the reason why these chips are so small. Let's see if I can flush that out. I don't normally put that much in there, but I need to flush out those chips. I think I'll put in another macro to cause the spindle to be raised up a considerable amount and then take it to the back of the table. Okay, let's flush that out again and take a look. No, see, that's not down far enough. I'm looking down in there and I still see metal. So I didn't go down far enough with my job. I only had it go 0.25 millimeter below the bottom of the stock. So I need to take it a little further down, probably half a millimeter. And then we'll start this whole job over again. Okay. You get to watch me go through that. How cool is that? So let's go to right display only. Let's get rid of the old Q3 job. So QA3 job is gone. Let's bring up the environment here. We're going to change the heights. And we're just going to change the bottom height. 2.5 millimeter. Get a good look at that. Oh, son of a gun. That was me. I'm the one that did that. I had it backwards. This is where I had it. That's where I had it. And that's backwards. It should have been a minus 0.25, as in 0.25 below. But I'll go ahead and take it down a little further. A half a millimeter below. That should clear out any flashing down there in the bottom of the hole. We'll click OK on that. See? See, now our path is coming through the bottom. That's what I wanted. It'll cut into the table, but that's fine. That's why it's called spoil board. If I had it all to do over again, I probably would have put some kind of a metal slotting, metal slatting on the table, and then put the spoil board on top of that. A little bit at a time. But I get the impression that you have to earn your right to do certain upgrades. You can't just go into it not knowing what you're doing. I'm going to call this QA3-2 to keep it from getting confused with any other QA job. It's my second attempt at doing QA3 plate. QA3 plate is the name that I'm giving to this particular plate. Yes, it's a Z-axis tramming plate, but for the purpose of remilling, it is QA3. That's its label. I find that when I keep things in context, it keeps my mind focused. Okay. There's nothing I need to do. I don't need to zero, don't need to do anything like that. All I need to do is start the job. And so I'm sitting here at the table with you, at the desk, and we're watching it on camera together. Give you a bigger camera to look at. So it won't have any problems with chip evacuation now. The mill is quite a bit quieter now that I've started to sort out speeds and feeds. I used to get a lot of chatter. And I could have second-guessed myself, but I didn't change anything about the position of the part. I know my speeds on my spindle. I do not dare go any slower than I'm going right now on the spindle because I just know my spindle on this type of hole. It's not a commercial CNC router, it's a hobby CNC router. So if I tried to do this much slower, odds are that the spindle would slow to a stop if I go too slow. And we're waiting for it to run. It is really quiet. That's what's surprising me. Yeah, we're over halfway there. And you have no idea how happy I am that this plate is done. This, I thought, was going to be one of the more complicated plates. It turned out it was not. It was actually quite easy. I did have problems with this plate initially, and I could tell by the workmanship on the front side of it that it does need some filing. I could, if I wanted to, do that edge with the CNC router. I might still do it, just because it gives me a faster solution. But I think part of me just wants to call this plate done. Stick it in a vise, file it down, call it done. Give me an excuse to mount the vise. I was looking at video of the Marconi lab when it was set up, and video of like the Marconi machine shop, and also the Colt machine shop, early Colt from the 19th century. And particularly in the Colt shop, they had cast steel vices. It was amazing to see. They had vices, very similar in design to what we have today. Okay, I'm gonna walk over there and get ready to take this thing off. Yeah, that's gonna be cut down enough where I can just pop it out of there. But I don't want to crack the tip of that bit. Let's see. And I'm looking down there and I see a lot of blue. We're good. Which is a surprise to me. I see blue. Alright, I can live with that. Let's go up. Let's go back. Get that out of the way. Make that screen go away so I don't accidentally hit it again. We need to get those screws out of there. But you can see for that little job I didn't need a whole lot of fastening. Yeah. There we go. So we're going to take this over to the workbench or to the desk and start wiping this thing down. We'll do another dry fit. This time I think I want you to see the dry fit in progress. I have to learn how to use the tramming plate. I've never had a tramming plate before. I got the idea from somebody else. I'm not selling this thing, so there's nothing to. I'm not going to be selling this as a product. I mean, selling it as a product would be wrong because it's not my design. Somebody else's design. I just thought that if I'm going to put that much force with these big old motors I'm using, the least I could do is get it right. And I thought that trimming plate just made sense. You never know what's going to happen in the future. You need to be able to improvise and adapt. Now, this is not a perfect hole. The slot is definitely not perfect. All the holes are not perfect. I'm actually not happy with some of what I'm seeing here, but it still will work. So I'm heating the aluminum with a choke cleaner. Yeah, it's going to do some oxidation on it, but it gets all the oil off real fast. All the lubricant's just gone, and the choke cleaner evaporates real quick. All right, there we go. There'll be some lubricant down inside some of the holes. I still am up in the air whether or not I'm going to tap these holes, and I might still come back and do something slightly different on these holes. I think I'm going to do some more milling on this plate, but I just haven't decided that yet. All right, so let's get the Z-axis up here. All right. First things first is get rid of the bits and pieces of the QA3 plate, job number 2, out of the system. We don't need that. I might still put this plate back on the router, but that won't be today. Okay. I've been in the doldrums, if you will, for a good part of the weekend, and I needed to just get to doing some work. I'm starting to feel better just because I'm working. All right, and let's get out of there, and let's bring it back up to the desk cam and get a drink of water. Okay, there's still a part I gotta sort out. I haven't sorted out yet. Okay, so this is the bottom. Let's get some of these out of the way. I keep small parts up here because I'm having to grab them so much. Okay, move things out of the way. Here's some bits. I've got bits up at the house I need to bring in here. I'm always having to grab these little bits and pieces of 20 series extrusion because that's what I mainly work in right now. Okay, here's where I've been keeping notes of measurements today. And this is another part that I got to install on another machine. Okay, all these out of here. And that can go right there. All right. So this is the bottom of the Z-axis. This is the top of the Z-axis where the motor will mount. There's the inset for it. And you see that we've got pre-drilled holes. These are these are actually tapped already. This all came as a single unit, and here you go. See that? And here we go. And you can see that the holes, I'll do that again, okay? Watch, the holes will just match up, even with the errors in the plate. The holes still match up. So let's get some screws in there to prove it. There's one hole that's very important, and that's kind of this little pilot kind of pivot hole. It's kind of important. There we go. So that's like the most important one. So you can see that. Now, if I put, I'll show you this at a different angle. Now, watch this. See that? I could put metal shims behind this and bring this out a little, right? That's the point. And also, because of the nature and the direction of this slot, and the nature and direction of that slot, and the nature and direction of this slot, I'm able to do some adjustments this way. This is the first time I've had all 4 screws in here. I got to sort out what kind of washer I want to put in here. I don't know what kind of washer I want, because if you can see here, that slips in there, and we don't really want it doing that, see? There should be a big washer up here of some kind. I have to sort that out. Haven't sorted that out yet. Okay. So there'll probably be a big washer there. Okay, and so this is the first time I'm giving this a test run. And I think maybe my slots might not be big enough. I'm thinking the slots need to be bigger. There's not a lot of movement in there. I wonder if the slots need to be angled. It's got a little movement. Not a lot, though. But even if it doesn't work as a trimming plate, it still works as a mount plate, right? So I'm not upset about that. I don't know. I need to see this in operation elsewhere, because my design, yeah, I'm thinking the holes need to be wider than 6.5 millimeters. But I'll take a look at the manufacturer who actually makes these and see if I can get some more information about the dimensions of these holes. There is some tramming happening here. Not much. A little bit. So that means the onus is on me to ensure that tramming is also accomplished elsewhere, and that this becomes like a fine tuning. Okay, so let's go get the piece that's actually going to go on there. I still haven't sorted out how I'm going to drill these holes yet. But that is the spindle mount. You can see it's a massive spindle, and that helps you understand why I'm doing all this thick aluminum. But yeah, I got to drill out the holes in here. And they got to be exact, and these holes will be threaded. They will be threaded. You can see that now. I did think about putting some cap screws underneath here and, you know, tightening it up coming up from the back. But I think that would become a problem. That would become a problem down the line if I had to go back in and tighten these up. It means I'd have to take the entire plate off. So I'll make sure that I can get to the heads of the screws this way, and I'll thread these. I did consider making these M6 screws, but because there's 6 of them, I decided to go ahead and make them M5. If I run into an issue where it actually shatters them in operation, I'll go back in and make those bigger threads, bigger holes. We'll see. We'll see. But yeah, you gotta start somewhere. And there also will be a little bit of movement here, but I wanted to put that movement here, and I'm just not happy with how much play there is right here. Yeah, distinct impression that these need to be wider, these 2 slots. Anyway, there you go. And so now we're going on, this will wind up becoming QA4. Well, QA3, job number 3, as I sort out what I've got to do with the widths of these 2 holes. So, not a bad day. We got a response. We actually got results. So, having results is better than no progress at all. So, thanks for visiting us today, and I hope you have a wonderful and blessed rest of your weekend.